And the Pandas package is the most important tool at the disposal of data scientists and analysts working in Python today, as Pandas is the backbone of most data projects. Understanding this, we have come up with this tutorial on Pandas. Now, before we go ahead with the session, I'd like to inform that we have launched a completely free platform called Create Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below.
So Pandas stands for panel data and is the core library for data manipulation and data analysis. So if you want to perform any sort of data analytical task, Pandas should be your go-to library. And Pandas provides single and multi-dimensional data structures for the purpose of data manipulation. So the single dimensional data structure is known as the series object and the multi-dimensional data structure is known as the data frame. We'll start off by understanding about the series object. So series object is a one-dimensional labeled array. So we have already worked with the NumPy array. So in NumPy array, we had no labels along with it. It was just a simple blank array where we had stored some values. But over here in a series object, as you guys see, we have labels, or you can consider them to be indexed with labels over here for these. So first we'd have to start off by importing pandas, which is the library, and we are giving this alias as PD. So import pandas as PD. Then if we want to create a series object, we'll have pd.series, and inside this I am passing in the values 1, 2, 3, 4 and 5. And when I print it out, I get this series object. So when I check the type of this, type of S1, this gives me pandas.core.series.series. Now over here, you'd have to keep in mind that S is capital over here. So if you're given a small s, you will get an error. So let's go ahead and create our first series object. So I'll just add the comment pandas. Now our first task would be to import the pandas library. So I'll go ahead and type in import pandas as PD. Let's just wait for this to be loaded properly. Now that we have loaded the library, I can go ahead and create the series object. So I'll type in pd.series where S is capital. Inside this, I'll pass in the list of values. So let's say I'll just have 10, 20, 30, 40 and 50, and I'll go ahead and store it in this object called as S1. Let me print out S1 over here, and as you guys see, I have created this series object. Let me also check the type of this. So inside the type method, when I pass in S1, you guys would see that this is a series object. And over here, we have the labels. So the labels are 0 to 4. So by default, the label or the index starts with 0 over here. So 10 is present at label or index 0, 20 is present at index 1, 30 is present at index 2, and that is how it proceeds further. Now, since we have labels in a series object, we can change how the label of the index looks like. So over here, we just had numbers starting from 0, but instead of numbers, let's say if I wanted alphabets over here, then I can add a new attribute called as index. So over here with this index attribute, I am setting the values to be equal to A, B, C, D, E. So here initially we had index 0. 0 has been changed to A. Then we had 1, 1 has been changed to B. We have 2, 2 has been changed to C, and that is how it proceeds. So now over here, let me go ahead and change these index values. So it is the same command over here. And with this same command, all I'm doing is adding a new attribute called as index. And I'll pass in a list of values for the indices. So I'll have A, B, C, D. Let me have D over here, and I'll have E. Now, when I click on run and I print out S1 over here, you guys would see that I have changed the indices from 0 to 4 to A to E. Now we can go ahead and see how to create a series object from a dictionary. So we have already worked with dictionaries. We know that the dictionary is a key value pair. So here we'll just give in pd.series, and over here we have 3 key value pairs. A10, B20, C30. So here automatically the keys are taken as the labels and these values are taken as the series values over here. Let me create a new dictionary. So I'll have D1 and inside D1, let me have 4 key value pairs. Maybe I'll have A and 10. Then I'll have B and 20. After that, I'll have C and 30. Going ahead, I'll have D and 40. Now I'll just go ahead and print this out. As you guys see, I have successfully created this dictionary. Now I would have to create a series object out of this. So I'll just have pd dot series and inside this I'll pass in D1 and let's see what would be the result. So these 4 keys which were present became the labels and these values over here in the dictionary became the series values as well. Now we can also go ahead and change the index position. So similarly, as we had actually changed the index values from numerical to alphabetical. So when I given the index values as B, C, D, A, this sequence is maintained. So I have B and C first. So for B, I have the value 20, C, I have the value 30. And D, we had not created any key with this particular index. So that is why we have NaN over here. And then we have A for which we have the value 10. So this is how we can maybe add a new index position or change the existing index positions. So this is what we had over here. This was our series object. And now what I'd want to do is, so instead of A, B, C, D, I would want, let's say, C, B, A, and D. And if I click on run, you guys see that the sequence has changed over here. Now we'll also see how to extract individual elements from the series object. So here we have all of these elements starting from 1 going on till 9. And again, you'd have to keep in mind that the indexing starts from 0. So if I want to extract this particular element over here, so the index value for this would be 3. So 0, 1, 2 and 3. And when I given the index value as 3, I am able to extract this particular element. And if I want to extract a sequence of elements over here, so if I want the first 4 elements, then I'll have S1 colon 4. This would mean that I am extracting all of the elements starting from index number 0 going on till index number 4. And since 4 is exclusive, so that is why we will only have till index number 3. So we'll have index number 1 going on till index number 3. And if you want to extract elements from the back side, here we'll have S1 and we'll type in -3 over here. So -3 basically means third element from the end. Third element from the end, when I given colon, this would mean third element from the end going on till the end. So this is the third element from the end over here. So that is why I'll have 7, 8 and 9. And this is how I'll be able to extract a single element, a sequence of elements from the beginning and a sequence of elements from the back. And let me just create a new series object over here. So I'll have S1 is equal to pd.series and inside this I'll pass in a list of elements. I'll have 10, 20, 30, 40, 50, 60 and 70. Now that I have this, let me extract this element which is present at index number 3. So I'll have S1, I'll have parenthesis, then I'll just go ahead and give in the index value. So index value will be 3. And as you guys see, I have successfully extracted this particular element. Now if I want to extract the first 4 elements, then I'll just give in the colon over here and I'll have 4. And as you guys see, I have extracted the first 4 elements. Now if I want the last 3 elements over here, then I'll have S1. Then I'll have colon and I'll type in -3, which would mean the third element from the last going on till the last element over here. And I have 50, 60 and 70, which are the last 3 elements. Now we can also go ahead and perform some simple operations on top of the series object. So if I want to add a scalar value, so initially we had this series object where the number started from 1, went on till 9. And if I just wanted to add the scalar value phi to all of the individual elements which are present in the series object, all I have to do is use plus phi. And as you guys see, 1 becomes 5, 2 becomes 7, 3 becomes 8 and so on. And we can also go ahead and add two series objects. Over here I have S1 where the elements are from 1 to 9 and S2 where the elements are from 10 to 90. And when I perform S1 plus S2, this would add the elements which are present at the same index position. So here we'll have 10 plus 1 11, 20 plus 2 22, 30 plus 3 33, and this goes on till the last index position over here. So let's go ahead and perform some basic operations on top of the series object. So I already have S1 over here, and these are the original values which are present in S1. Now I'd want to add 10 more to these existing values. So I'll just type in S1 plus 10, and as you guys see, the values, all of the values which are present in the series object have been incremented by 10. Now also I can add two series objects together. So in the series object I have 7 elements. I'll go ahead and create S2 where I'll have 7 more elements over here. So I would have to type pd.series, and inside this let me just have 7 6 5 4 3 2 and 1. Let me print out S2 for your sake over here. So we have S1 and S2, and when I perform S1 plus S2, this is the result which we get. So 10 plus 7 becomes 17, 20 plus 6 becomes 26, 30 plus 5 becomes 35, and this proceeds to the last index value. So that was all about the series object, which was a single dimensional labeled array. Now we'll work with a data frame, which forms the major part of all of the machine learning data science projects. So what exactly is a data frame? It is a two-dimensional labeled data structure. And if you'd have worked with SQL or maybe Excel, you would have dealt with tabular data. And a data frame helps you to deal with tabular data in Python seamlessly. So a data frame, because this is a tabular data, consists of rows and columns. Now let's see how can we go ahead and create a data frame from a dictionary. So to create a data frame, we'd have to use this particular method over here. We'd have to type in pd.dataframe, where D is capital and F is also capital. So by any chance, if you give maybe D as small or F as small, you'll get an error. So both of them have to be in capital case. And over here, I have two key value pairs. So the first key is name, and then we have a list of values which are Bob, Sam, and Annie. Then we have the next key, which is marks. Then we have the list of values for marks, which are 76, 25, and 92. So here, as you see, the keys become the column names and the values become the records over here. So name and marks become the column names, and these values over here, the list of values Bob, Sam, and Annie, which are the values for this key, become the records of this particular column. Similarly, these values are there for this particular key, and these become the records for this particular column. So let me go ahead and create a first data frame over here. So I'll just go ahead and type in data frame. Now to create a data frame, I'd have to type pd.dataframe, and D and F both have to be capital. And inside this, I'll create a dictionary. So to create a dictionary, I would need curly braces. So the first key would be name, and I'll go ahead and give in a list of names over here. Let's say the first name is Sam. Then we have Annie. Going ahead, we have Jennifer. Now, once we have the first key value pair, I'll go ahead and also add their marks over here. So the second key would be marks, and I'll have a list of values over here. Let's say Sam has got 50 marks, Annie has got 60 marks, and Jennifer has got 70 marks. And I'll go ahead and store this in df. Let me print out df over here. And we have created our first data frame, where the column names are name and marks, and the values are these over here. And let me go ahead and also show you guys the type of this object which I've just created. So inside this type method, I'll be passing in df. And as you guys see, this is pandas.core.frame.dataframe, which basically means this is a data frame object. Now that we have created our first data frame, we'll perform some basic functions on top of a data frame. We've got head, tail, shape, and describe. So we'll just implement all of these. Now to implement this, we will be performing them on a data set called as the iris data set. Now to read any CSV file, we have a method called as pd.read_CSV. So here I'll have pd.read_CSV, and inside this I'll give in single quotes and given the name of the file. So the name of the file will be iris.csv, and I'll go ahead and store this in a new object called as iris. Now let me hit on run. Let me check the first 5 records which are present in this iris data frame. So if I want to check the first 5 records which are present in this iris data frame, I need to use the head method. So iris.head, as you guys see, I have the first 5 records. So this iris data frame comprises of 5 columns which are sepal length, sepal width, petal width, and species. And we'll have 3 different species which would be setosa, versicolor, and virginica. So this is how we can work with the head method. Now, similar to the head method, we would also have the tail method, which would give us the last 5 rows which are present in a data frame. So here I'll type iris.tail, and when I click on run, you guys would see the index value over here. The index value starts from 145 and goes on till 149, because there are 150 records in this iris data frame. So we have extracted the last 5 records and we have printed it onto the console. Then if you want to check the number of rows and number of columns which are present in this iris data frame, we can just use the shape method. So here I'll have iris.shape, and as you guys see, this gives us a dimension value of 150, 5, which means there are 150 records and 5 columns. Then we'll have the describe method. So here I'll have iris.describe. And now when I click on run, we have all of these numerical quantities over here. So let's say if I want to find out what is the minimum value which is present in the sepal length column. The minimum value present in this sepal length column will be 4.3. Similarly, what is the maximum value in sepal length column? It will be 7.9. What is the mean value? It will be 5.84. So these are some interesting metrics which we can find out with the describe method. So now that we know this, let's actually see how can we extract individual records or individual columns from a data frame. So for that purpose, we can use the .iloc and loc methods. So let's start off with the .iloc method. So .iloc method, with the help of it, we can extract rows and columns on the basis of index. So here iloc basically stands for index location. And over here, as you see, I have a comma, and on the left side of the comma, that would indicate all of the rows, and the right side of the comma, that would indicate all of the columns. So from this entire iris data frame, I am extracting the first 3 records. So here the rows would be 0 to 3, and 3 is exclusive over here. That is why I'll have the records where the index values are 0, 1, and 2. And similarly, the columns would be 0 to 2, which would mean the column which is present at index 0, which will be sepal length, and the column which is present at index 1, which is sepal width. 2 again over here is exclusive. So let me go ahead and extract some rows and columns with this iloc method. So we already have this iris data frame with us. Let me again print out the head for you guys so that it will be easier for you to have a glance at this. Now let's say from this entire data frame, I would want the records from index number 30 going on till index number 40, and I would want the columns which are present at maybe index number 3 and index number 4. So index number 3 will be 0, 1, 2, and 3. This is index number 3, this is index number 4. So here I'll have index number 3 going on till the end, because this is the last column. Let me print this out and show you guys the result. As you guys see, I have extracted all of the records starting from index number 30 going on till index number 39, and the columns which you see starts from index number 3, which is this particular columns index, and goes on till the end over here. So this is how we can extract individual rows and columns with the .iloc method. Now we have the .loc method. So instead of giving the column index, if I want to extract columns on the basis of their names, then I can go ahead and use the .loc method. And over here, when it comes to rows, you see that I've given 0 to 3. here when it comes to dot lock, you'd have to keep in mind that 3 is inclusive. This is the only case where maybe you will find that the final value over here is inclusive. So when I given 0 to 3, you will get all of the records starting from index number 0 going on till index number 3, which is also inclusive. And over here I'm giving in the column names, which are sepal length and petal length, and that is what I'm extracting over here. So I have this iris data frame, then I'll just go ahead and use this dot lock method. Now from all of these records, let's say I'd want all the records starting from index number 10 going on till index number 20, and the columns which I'd want to extract are sepal length and petal length. I'll just have sepal dot length over here, and the next column which I want would be petal dot length. Let me hit on run, and as you guys see, I have all the records starting from row number 10 going on till row number 20, and 20 is also inclusive over here. And the columns which I've extracted are sepal length and petal length. Now we'll see how to drop a particular column. So many a times it would happen that not all columns which are present in a data frame are important. So from this entire data frame, if we want to drop a particular column, then we can just go ahead and use the drop method. So here I'll have iris.drop, and I am dropping or removing the sepal length column from this entire data frame. So here, when I set the axis value to be equal to 1, this would basically mean that I am dropping a column. So if you want to drop a row, then you'd set the axis value to be equal to 0. And if you want to drop a column, then you'd set the axis value to be equal to 1. So if from this entire iris data set, again, I'll show you guys the head of this so that you guys can have a glance at all of the columns which are present over here. So from all of the columns, if I want to drop the species column, all I have to do is type in iris.drop, and inside this I'd have to give in the name of the column, which would be species, and I'd have to set the axis, which will be equal to 1 because I'm dropping a column. And as you guys see, I have successfully dropped the species column from this entire data frame. Now similarly, if I want to drop some particular rows which are present in this data frame, so here, as you guys see, the index value, it starts from 0, goes on till 4 over here. But if I want to drop the row indexes of 1, 2 and 3. Here, as you guys see, I have two parameters. First parameter, I'll give in a list of all of the indices that I'd want to drop. So I'd want to drop the index value 1, index value 2 and index value 3. And the resultant which you see over here, after 0, we directly jump on to the index number 4. So now from this entire data frame, this what you see over here, I'll just use iris.drop, and I would want to drop the index values of 1, 2 and 3, and I'll set the axis to be equal to 0. And when I hit run, you would see that after 0, we are directly jumping onto index number 4. So this is a very simple example of how to drop some records and how to drop some columns from your data frame. Now we'll go ahead and work with some simple pandas functions. So from the iris data frame, if I want to find out the mean values of all of the columns, I can just go ahead and use the mean method. Similarly, if I wanted the median values of the records of all of the columns, then I'll just go ahead and use the median method. Similarly, if I wanted to find out the minimum value, I'll use the min method. And if I wanted to find out the maximum value, I will use the max method over here. So very basic operations. So when I use iris.mean, this would give me the average values of all of the columns. So average sepal length of the entire data frame is 5.8. Average sepal width is 3.05, average petal length is 3.75, and average petal width is 1.19. Similarly, if I want to find out the minimum value of all of the columns, so I'll have iris.mean, and this will give me all of the minimum values. And if I want to find out the maximum values, I'll just go ahead and type iris.max, and this would give me the maximum value of all of the columns over here. So I've got the mean value, the minimum value, the maximum value, and I can also find out the median value. So I'll just type in iris.median, and when I click on run over here, this would give me the median values with respect to all of the columns which are present.
This brings us to the end of this tutorial on Pandas in Python. Now, before you guys sign off, I'd like to inform that we have launched a completely free platform called as Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. Thank you very much and have a great learning ahead.